Hello everyone, welcome to another lesson of physics. Today we'll be talking about vertical forces with elevators, which is a way to accelerate someone. So vertical forces. These are problems with forces in the vertical direction, and they are no different than any other force problem. So just like all of our problems, we are going to start with a free body diagram, and then next we will create our sum of forces equation in the y direction. And when creating our sum of force equation, you'll need to determine the following. What the object is doing. So if the object is moving with a constant velocity or it's at rest, then we will say that the sum of the forces in the y direction is equal to 0 newtons, just like we've done before. But if the object is accelerating upward, then we'll find that the upward force is greater, and the sum of the forces in the y direction is equal to F net. If it's accelerating downward, then the downward force is greater, and we still get the sum of the forces will be equal to our net force. An important note here, so we're going to choose the direction of motion to be the positive direction in our equations. Now let's take a look at an example of a vertical force problem. So during an exhilarating physics experiment, a student stands on a bathroom scale in an elevator. So let's create a free body diagram for this student. So as they are in this elevator, standing on their scale, there are going to be some forces acting on them. So we have the force of gravity down and the normal force up, but none other in the x direction. So if the mass of the student and his kitten peanuts is 75 kilograms, what is their combined weight? We also have his cat Peanuts up here, just like that. So their combined weight will be Fg equals mg, so 75 kilograms times 9.81 meters per second squared. We'll find that their combined weight will be equal to 735.75 newtons. Now, if the elevator is traveling upward to the second floor at a constant velocity, determine the normal force exerted by the scale on the student. So if it's traveling upward with a constant velocity, then we're saying that the net force is equal to 0, which in this case, we can assume that our force of gravity will be equal to our normal force. So our normal force will be equal to 735.75 newtons. Okay, so if the elevator is accelerating downward, back to the first floor at 2 meters per second squared, determine the normal force exerted by the scale on the student. So we'll write out our acceleration. It's going to be equal to negative 2 meters per second squared. So from here, we can find what our net force is equal to. It's equal to mass times acceleration. Plug in our mass of 75 kilograms and our acceleration of minus 2 meters per second squared. And we will find that our net force is going to be negative 150 newtons. So now we want to find the normal force exerted by the scale on the student. So we can write out our sum of forces equation in the y direction, which is also equal to our net force. We can say this is our normal force minus our gravitational force. Now, our gravitational force or our weight will not change, so it's going to remain as it was before, which was 735.75 newtons. Now we're looking for our normal force. We found before that our net force is minus 150 newtons. So now if we solve for our normal force, we'll find that it is equal to 585.75 newtons. All right, so we can notice the difference from the normal force before when the elevator wasn't moving to when it started accelerating. Let's take a look at some important facts that we should know when we're doing some of these vertical force problems. So the scales tell us the normal force required to keep us from falling through the floor. And as we saw in an earlier part, this is usually equal to our weight. However, as we saw in part 4, if we are accelerating down, then normal force will be less than our weight. So the scale will read a lower number than our actual weight. Right, so let's do another example of this. So during a follow-up experiment, a second student stands on a bathroom scale in an elevator. So again, let's draw our free body diagram for the student. So we have the force of gravity down and the normal force up. We don't know how they compare yet because we don't know which way the elevator is moving. So if the mass of this student is 90 kilograms, what is the student's weight? So we can use our weight equation, Fg equals mg, plug in our mass of 90 kilograms, times g, which is 9.81 meters per second squared. And we will find that our weight is equal to 882.9 newtons. So the elevator is at rest on the first floor of the school. Determine the value that the scale reads. So in this case, we're just going to see that our normal force is equal to Fg, because if it's at rest, our net force is equal to 0. So we'll find that our normal force, if it's not moving, is 882.9 newtons. Now, the student hits the button for the second floor and begins to accelerate upwards at 2 meters per second squared. What number appears on the scale as the student accelerates? So again, we want to write out our acceleration, which will be 2 meters per second squared, which allows us to find our net force, which is equal to ma. Plug in our mass of 90 kilograms times our acceleration of 2 meters per second squared. We'll find that our net force is going to be a positive 180 newtons. So just like before, we can set up our net force equation, this time our sum of forces. So it's going to be equal to our normal force minus our weight. We can see that our net force is 180 newtons to our normal force, because that's what we're looking for, minus our weight, which we found to be 882.9 newtons. So now we can solve for our normal force and find that is equal to 1062.9 newtons. All right, so for this one, since the scales tell us the normal force required to keep us from falling through the floor, which is usually equal to the weight, but in this case we can see that if we are accelerating up, the normal force will be greater than our weight. So the scale will read a value higher than our actual weight. So in summary, we will observe that in an elevator accelerating up, we'll have a net force up, perceived as an increased weight. An elevator moving with a constant velocity will have a net force equal to 0, and you will not perceive any effect. An elevator accelerating down will have a net force down, and this will be perceived as a decreased weight. All right, so that's it for this week. I hope you all have a great rest of your day.